choose our own AI. We'll explore. Help the future hand in hand in this tech-driven wonderland.
Okay, hello everyone. Hope you're having great time. I'm sure there's a ton of people in Singapore right now, but for those who are with us, welcome. And we have here Bidhan from Bagel. I'll let you introduce yourself, and we can kick off with some questions from both sides.
Yeah, sounds great. Hello everyone, and thanks NEAR Foundation for having me for this session with Illia today. My name is Bidhan. I'm the founder of Bagel. Bagel, we explain Bagel as a research lab. We do research on AI and cryptography, and we recently launched a product which is called the bakery, bakery where bagels are made, which is a decentralized model fine-tuning platform with privacy and monetization for the models and data sets on it. My background is both kind of in the machine learning and cryptography space. I used to be the AI ML infra lead for Amazon Alexa. So my team was responsible for delivering the wake word model to more than 100 million Alexa devices around the world. And my journey in crypto kind of started back in 2017, where I was in the founding team of the Bitcoin trading platform of Cash App. And for them, I was doing some anti-money laundering machine learning. But then I got to know about Bitcoin. So like, hey, this great thing, you don't need really any bank to send money. And then learned about Ethereum, learned about NEAR, like all of those other different options, kept going down the rabbit hole, never looked back. Yeah, and recently before doing Bagel, I was the ecosystem lead for a layer 1 blockchain.
Awesome. Well, great to have you here, and excited to learn more kind of how you're approaching what you're building at Bagel and bakery, as well as I know you have some questions for me. So maybe we can kick off. Yeah, like I'm curious, how you see the space on kind of Web3 side. Obviously, you guys, I think, doing more go-to-market on the AI side first, right? To then bring Web3 to them, which I think is very important as well. But yeah, we can just kick off there and kind of go from there.
Yeah, totally. So we see ourselves as AI first, and blockchain side of the things are more of an implementation detail. So I personally see blockchain as a coordination technology, which allows multiple people who are probably not co-located at the same space, who probably don't trust each other, who probably haven't even met each other in any way, like haven't shaken hands to build any trust between them. They can come together and collaborate with each other in a permissionless way. So that's what blockchain enables fundamentally. And that's how we enable, that's how we see the usage of blockchain within the product that we're doing. And you're right, like we are doing the go-to-market in the Web2 AI space first, because we feel like that's where the most of the demand would come from. Like we are a decentralized model fine-tuning platform. Who will fine-tune the most models? Like people in the Web2 community who are like smaller startups. We want to support the longer tail of startups who are using our fine-tuning models for various use cases. So that's the crowd we go after. And there has been some interesting challenges, when we try to go pitch them a blockchain-based solution. Some of them love blockchain, some of them not so much. We are being creative in how to solve that issue. But to summarize, that's how we see it. We see most of our users coming from the Web2 space, not the Web3 space.
Yeah, I mean, totally makes sense. I think the audience there is definitely, dramatically bigger. And I think there's an interesting aspect that is somewhat underappreciated in Web3, is that Web3 companies actually have very little data of their own, right? There's obviously a lot of like on-chain data and Twitter and other public info, but compared to Web2 companies who are actually like in the business of collecting data, there's less data available on Web3 side, kind of by design. And so there's just less possibility to do interesting things there as well, at least at this time. I think we'll get there as we're building out a little bit more of a framework, like in this user-owned AI side. But
actually,
okay, so it makes sense.
Yeah. Sorry, go ahead.
No, go ahead.
No, I totally agree. Like, whole point of this user-owned AI is that like all the resources are not owned by the platform itself. In Web2, if you're doing something, you have to first start by finding the resources and own it yourselves. That's how you give the service to the users. But in Web3, we have the superpower is that we can let users own the resources themselves and coordinate with each other. And we become the coordination mechanism in the middle, right? So yeah, I totally agree with you on the sentiment.
And so on the kind of if we pick under the hood of the bakery, how does the coordination, like, are you guys doing like multi-node fine-tuning, or like you just kind of distributing load between individual nodes?
Yeah. So we are doing actually a really interesting thing, like we're doing like edge compute. So also we are kind of like almost in stealth still. So happy to like go really super deep with you, Illia, like when we talk like one-to-one sort of in public, but I'll just glance over it a bit. We have this technology, which we called GPU restaking. It's a kind of like a flashy name to get attention, but what it is actually, we have partnership with decentralized networks. For example, we have partnership with Filecoin Foundation, where we are getting all the miners from the miner network to provide their hardware to do the compute on our platform. And we call it GPU restaking because the hardware is being used for mining and being used for the AI workloads from the bakery at the same time. So it's like used in multiple places. So, and what that enables us is enables us to do edge compute, because if it's a data center which has the storage and the compute, we can make sure the storage, like the data sets and the compute, are co-located. That's kind of the deal we have with all of these data centers. And then that gives us way better performance in terms of the AI workloads that we do, instead of like, let's say AWS, because on AWS, you have something on one region and all the other resources in another region. They're not co-located, so there's this latency still that's going on, right? So that's how we basically do it under the hood in the bakery in terms of like the compute side of things. And yeah, so that's like the performance side. And we also provide other advantages over centralized solutions, like, Hugging Faces of the world, is that we allow the users to monetize their resources too. So it's like there's a tradability aspect of the models and the data sets on the platform. And the third part of it is privacy. So if you don't have any privacy of the resources, you cannot monetize. Like on Hugging Face, you share your data set, it's open for the public. Nobody's going to buy it from you, right? And it doesn't also incentivize high quality resource owners to provide the resources. So you also enable privacy. And how we do the privacy, we use solutions like differential privacy. We are working towards using solutions like fully homomorphic encryption, which is little down the line because the technology is still not ready for prime time. But that's how we see the future.
Nice. Yeah. No, I mean, those are definitely important concepts and pieces, as well as, how do we do kind of federated training or more distributed training over like a kind of just very decentralized network, all of the research topics that people
like for federated learning, we have seen some challenges. Is that so we in our Web2 customer discovery, like I personally have talked to like thousands of people. I'm pretty sure you have as well. I mean, you have been in the space for way longer than I have. But so what we saw is that in federated learning, you actually have to reveal the model to a big amount of users. Like you're sending the model to all the data owners, right? And the data privacy is preserved to a certain extent. But I mean, that also is questionable somewhat. There's like model distillation attack where you can get the data out of it anywhere. But at the same time, a lot of the users that we were targeting, they were not open to sending their proprietary model to all this massive amount of data owners, right? So you preserve the data privacy in federated learning, but you don't necessarily preserve the model privacy there. And that was one of the blockers from our end to do the federated fashion, like something we are not exploring. Federated learning works great when it's all open source model, right? You send them, you get the weights, you aggregate them in centrally. But a lot of the Web2 AI companies are not like using totally open source. They have some of their proprietary solution baked in there.
Makes sense. Yeah. Yeah. I mean, all of these that definitely like depends on the use case and on kind of, do you want to reveal the input? Do you want to reveal the model? Do you want to kind of collocate compute or distribute compute? And so you get like different parameters depending on those choices.
Yeah. And we wrote a like really, I mean, quite popular by now is that a research blog post on our blog, blog.bagel.net. It's called "With Great Data Comes Great Responsibility." Like it's kind of a pun to Spider-Man. I'm a big Spider-Man fan myself. And in that, we kind of like did in-depth research. Like, what does it mean to use differential privacy? What does it mean to use federated learning? What does it mean to use ZKML? What does it mean to use fully homomorphic encryption? TEEs, MPCs, like all the fancy things that's also now coming. And what we realized is that, like in short term, a lot of the solutions have to work together. Like there's no end-all, be-all solution, right? Like you have to mix ZK with differential privacy sometimes, like some of the things that we are doing, or you have to do federated learning in some fashion. Like, but no one solution can support the end-to-end privacy that you're looking for. So yeah, but in the longer term, I personally see a lot of value in homomorphic encryption. That's, I kind of see the future when it's scalable.
Yeah, well, it's an interesting question, like how scalable can it get? Because definitely the current performance is still pretty far from what people are looking for.
Curious, what's your opinion on this, on the privacy side of things, at least for AI?
Well, I think it all depends on indeed the use case and kind of the requirements, right? I kind of, the way I think of it is from like a user type more. So like if I'm an individual consumer user, right, like my data is probably not that big, and like it turns on my device or kind of, in my private cloud, like privately encrypted data. And so I want my assistant agents, etc., to access to that. I think this is where you can either have, either completely local stuff, or you have the fully homomorphic encrypted like retrieval augmented generation, right? So
yeah,
the k-nearest neighbor over fully homomorphic encryption is relatively performant operation, right? It's just a kind of
interesting
2-vector multiplication. Yeah, so that part is like possible, and we're working with few folks who have been working on a solution for that. Then if we're talking about like bigger, either like a community or a company, right, where you have like a group of people accessing some data and you want like a fine-tune a model for that, or model that can access to this, that's when things become more complex, because indeed, like ideally you don't want to move data out of your kind of private cloud.
Yeah.
So ideally you bring the model to it. And so then, like, is the model open source? Then it's easy to bring to it. You just need to find now, like, is your private cloud offers compute? That's a separate problem, right? Like, in this case, are you trusting Amazon, or you like running, on-prem, or you're running kind of in a distributed way in the first place? So all of like those are all different, like, things that you need to handle. I think right now, again, like if you're in private cloud, you probably are in the cloud already, and so you can just leverage the compute that exists there.
Yeah.
or I'm curious about actually some of the HGX that the GPUs like H100s are going to be offering, like what is the trade-offs there, and then there's another. So then you go to next level, which is like if I want to kind of sell my model without revealing it, right? That's where things get harder. And I'm not sure that's like I'm not fully convinced that that's a use case we should be optimizing for, because models in the way are becoming more and more of a commodity. And I think keeping them open source is useful, and kind of like building around that the models are open. But there is an opportunity to build something where potentially you don't have anyone having all the weights at once, right? And like nobody can like collect them kind of at the same time, and you just have enough like, you have some form of ratio coding, right, where like data is like distributed enough, and you can like you do maybe more computation than you would need if it was all collected in once, but then you kind of have this model as like a result of lots of machines kind of working together with some parameters around. So that's more closer to what we usually consider in like in Filecoins, and not in like in blockchains, right, where you have like larger number of replicas that are together able to achieve some result. I mean, Filecoin actually has a somewhat similar design, right?
Exactly.
And so I think that is like an interesting like place in the trade-off set, where the model is accessible, it's potentially like guarded by a set of criteria, but it is not like also owned by any individual party, right? And I know some people are trying to achieve that, so that's why like it's kind of a spectrum on one side, and then like you go from I run it on my on my phone like edge model to like I want to run it in my cloud, to I'm running somebody else's stuff maybe in SGX, to like I want to run it across like a kind of this decentralized network.
That's interesting.
And then you have like another dimension, which is like where data lives and like how it travels, right? And so you have kind of like places in this matrix, like where you want to be.
Yeah, totally. I'm curious to know about your thought on the inference time compute things that's like kind of came into limelight. Even though this has been the case for me, I feel like RAG is an inference time compute thing, and we in the bakery we provide RAG and fine-tuning both. Like for me, RAG is like the shallow fine-tuning thing where you don't change the weights, and the deep fine-tuning where you change the weights. So we as Bagel were one of the first players in the decentralized RAG space, and we have always liked it, but it kind of like lost to the limelight. But coming back with the inference time compute kind of conversation that are happening. But then I also feel that even though model is open, all the weights are open of the model and the algorithm. At the same time, if the mode goes to the inference time compute, like whatever you do with like chain of thought or RAG or whatnot, and then some of this still stays like kind of private and proprietary, even though the model itself is open. Do you think curious to know your thoughts on that?
I mean, I think that there's like, again, multiple dimensions here, right? I mean, definitely inference time compute in general is is a direction this has all been going, right? Like I think everybody was prompting this chain of thought. Indeed, I think thinking of RAG is also like an inference time compute is a good way. Like how do you reduce really large context, right, down to something that like you can process effectively. I mean, in a way, like the agentic frameworks, right? That's like run multiple times as well. It's the same thing.
Yeah.
That's like one of the things we've been looking at as well.
It's just multi-shot. The inference time compute is basically multi-shot instead of one shot.
Well, not just multi-shot, right? It's you can you can imagine it like editing its context. It can do a lot of things, right? So like you have it can indeed like edit. I mean, it can like, okay, forget about what I was thinking. That was wrong direction, right, etc. Or you can have a search even at inference time where you like search different options and kind of score them with a different model even. So there's a lot of things that potentially can be done here in this framework. But I think, yeah, I mean, same as we people, like we don't try to immediately respond to the question. So I think that the interesting thing here is going to be now, like for the models, we kind of need to start evaluating them not just based on like how good they are at answering questions, but how fast they are, or like how much compute they spend on answering questions, right?
Yeah.
And so there's going to be like, you're good at math at 90% in 5 seconds, right? Versus at math 90% at like 100 seconds. So I think that would be interesting kind of dimension that we're going to add. And then I think that's where a lot of the systems that actually have rugs and other systems, like other like information and structure, and will become very relevant, because like that's actually how people think about this, is like, how fast can I get my answer, how cheap can I get my answer, and how correct it is.
I also think
and then
it's sorry, go ahead. Finish.
No, go ahead.
I also think it's actually a good way to democratize the space. Like right now, I'm talking about the hardware kind of. Right now, NVIDIA has almost like a monopoly on the training side of things. But if the more and more compute moves on the inference side of things, where they have less of a moat, I think that also opens up a lot of the hardware playground. Like a lot of different players can come together. And so then the monopoly is not there anymore, right? Do you think it's the same way about this?
Well, I don't know. I think NVIDIA is still there. I think we'll see some interesting aspects around, like, if most of your training is spent on like unrolling like long chain of thought, etc., right? And kind of scoring them, you don't need as much interconnect, right? Like you can assume, some parameter server model where you have a lot of replicas that are able to, they're just like unrolling the potential candidates and then scoring them, and then like only sending potentially updates from the ones that actually found like the right response. You can have a lot more kind of distributed setting and training setup. And you can use ARM, and you can use, Exa's doing a great job with like using ARM, for example, and M3 for stuff like that, for inference. So like, I think there will be just like a lot more experimentation here, but I don't know if it's gonna H100 is just, and obviously Blackwell is just still generically a better tool for a lot of like kind of stuff. And so like, and the optimization between like how much energy it uses versus how much compute you get, because I think at the end, like, this is something people forget. At the end, it's also about energy, because that's actually your base cost. I mean, yes, there's like mass and margin of NVIDIA, but there's like also just how much electricity you're burning. And so whoever has like a good balance there and has good software. And I think the other piece that's been kind of limiting is like nobody was managed to get really good software for these devices. So yeah, I'm not convinced that this monopoly is ending yet, but I think we'll see more setups and experimentations here.
That makes sense. Yeah.
How are you thinking about it?
Yeah, I also think the same, but I also think it's like this community hardware comes into play, and that kind of opens up the as you mentioned, like EXO, like they're one of the players in this space. As the community hardware comes into play with the inference time compute, I think that also opens up a lot of opportunities for coordination of different actors owning this community level hardware. at different locations, and how do you let them collaborate with each other in a trustless manner? That's where more of the use cases of blockchain opens up as well, right? So training historically has been, even though a lot of people are working on the decentralized training part as well, but historically has been like a lot of co-located things. But inference opens up the playground in a lot of ways. And I kind of foresee a lot of blockchain-based products and use cases in that area.
Yeah, I mean, well, there's already a bunch, right? That's
Yeah, exactly.
Yeah.
So Ilya, I actually
Yeah, I think
I couldn't, but I couldn't help but notice your background. I actually had the question for you before, like, what's the context behind the Black Dragon name?
well, it's just like back from I was 10, that was my like username for video games and whatnot. So it just kept, kept staying with me as I was growing up. And so at some point I probably had an opportunity to change it on like Twitter and GitHub, but then it passed, right? And now it's like now I'm just living the meme now.
No, I like it. Black Dragon is great. And yeah, I mean, there might be some even interesting meme probability with Black Dragon and maybe Transformer, like mix it together, some kind of pun because of your work in the Transformer as well.
Yeah, Transformer Black Dragon. That's I'm typing into ChatGPT to generate me one right now.
Yeah, fair enough. But also, like, I guess if we're talking about the Transformer stuff, I mean, I have read about your work in Transformers, like a lot of hundreds of thousands of people around the world, right? Then I'm curious that, if you had to kind of re-implement Transformers today in a decentralized fashion, right? Like, have you ever thought about it? What did you do? Like, let's say you had to, change the architecture. What would be the approach?
Yeah, that's a very interesting question because, I mean, one important part about Transformers is that it was optimized for the highly parallel hardware, right? GPUs, pretty much.
Yeah.
And a lot of the motivation came from the fact that, like, hey, we can actually do a lot of matrix multiplications in parallel, a lot more than you can do like if you just sequentially read words. And so you can do a lot of this, like, let's just read everything in parallel and then kind of make sense of it over time, right? With like few layers of the transformer. Now, if you assume, and this is a question like, okay, when we say decentralized, what does that mean, right?
Yeah.
So if we assume like what I was saying, like, hey, we have this like decentralized cluster pretty much of machines that are like continuously learning and updating and doing stuff, right? Well, the architecture should be different, right? Because like you don't have this interconnected parallelism anymore, right? You have a different type of parallelism.
Yeah.
You have like almost like normalization that comes from the fact that like some nodes will go down and people see different, like people feed different data from different sides. So you kind of need like a different architecture at the core. And then on top of it, the interesting thing has been that the GPT part, right, is coming from this like, hey, let's just like run a language model over internet. And it's definitely, clearly very powerful concept. But even now, you can imagine you can take a GPT model and generate a data set, right? And this is kind of what O1 is like, you can generate a data set now that is different. That is like actually for more about like taking a question and taking a problem and trying to solve it and getting a solution and training on that now, not on predicting the next step, but on actually solving the problem. And so you're changing the value function. And so here you would also potentially, can consider changing value functions as like kind of distributed cluster. Now, how exactly this would all work together, I don't have like exact details, but those are just the concepts that like, okay, we don't have like immediately access to the whole context of everything, but we have, let's say we have 1 million machines, we have millions of contexts, right?
Yeah.
And so how do you reason between them? How do you interconnect them? Well, you want a different architecture, right? To optimize for that. But at the same time, you have this, like you want any information to be encoded in multiple places in this. You want to be able to potentially even recover some information you lost and like detect that some information got lost.
Yeah.
I think the thing that's kind of the most, I think the most unclear part is just because like a lot of the basic skills, right? Like I can kind of understand how the math works of the neural network to actually do, right? Copying the answers, finding semantic matching, doing some things. Where it gets really unclear is like some higher order logic and higher order reasoning that this like transformers now show at like large parameters, like this transition that we see from 70 billion to like 400 billion or above. Like even that transformation is not very clear. Like some of the scales that it's able now to do, it's not very easily explainable. Just like, hey, even if it's the same amount of data or whatever, right? Like why the change of parameters allowed it to do like such a better job at reasoning. And so that one is a little bit hard to think through how to apply in kind of more decentralized distributed space. So everything else I think it probably can map like like how to store information, how to retrieve it, because like those we have as simpler concepts we can reason about and kind of expand them to this distributed set, right? Anyway, I've actually been thinking about this, and we're planning to do like maybe a reading group in one of these times for this office hours to zoom into like this different approaches around like distributed and decentralized learning.
Yeah, no, that's fascinating. I personally have spent a lot of time, like at some point, not recently, like how to do a distributed attention mechanism. It's like how to make it like how can you distribute it over a geographically distributed set of nodes, but still maintain a global context for that. And I think there are some work on that, but it hasn't been explored that deeply. But the best solution I could come up with over during my exploration was like you do some kind of a hierarchical tree kind of approach. You get the nodes, you get the attention, and like get them one, and at the center, like whatever being coordinated, that's the root of the whole tree. That seems like that could be something that could work for the attention mechanism at least, and which seems to be the hardest part of this.
Yeah, in a way, like the RAG is a form of like very basic attention as well, right? It's like find. True. It's just not. It's not a. Like, you bring it back into like the text space to feed it instead of bringing the vector space, and usually RAG is done by like a simplified version of embeddings, right? You don't have like this multi-step reasoning stuff, but then RAG itself can be scaled a lot wider. So yeah, I think there's interesting concepts there. I think the other one is just some form of mixture of experts, right? Where you actually routing to different nodes and different who may be experts in different aspects of things, right? So maybe some node is more trained on medical data and some node is trained more on astrophysics data, etc. You can imagine that setup as being kind of effective way to like packaging data on different nodes. And then you still have like some more high level reasoning nodes that kind of take over from there.
No, makes sense. Sounds like you personally are very bullish and interested in the RAG framework itself, like instead of like putting information into models, and that kind of allows for better privacy as well, because the RAG at least preserves a lot of information after the encryption stuff, like homomorphic encryption. Is that right?
Yeah. Well, I think it's definitely part of the architecture, right? Because I mean, it's a little bit strange to assume that we can like plug in all data into a model, right? Because model is fixed number of parameters, right? So if you keep plowing stuff into it, like ideally you actually want model to be the like just purely intelligence, right? Like it just does reasoning, it does logic, it does thinking. The problem is that there's no such thing as pure reasoning. Like you're doing like most of the reasoning we have is like based on some common concepts. And the problem is common concepts. There's no such thing as common. Like it's all, you know, is Apple a common concept? Is Earth a common? Like it's a spectrum as well, right? Like people are definitely not common concepts, but like as you get closer to, you know, kind of more like an object is a common concept, and like you should be able to reason about objects. And so like where is that like line? Like it's the same as, you know, if you teach a kid only about like, you know, sciences and then never expose them to anything else, right? They will have a very limited worldview and ability to reason about things.
True.
So, but then all of the data, like, you know, oh, this movie star did that, etc., which right now this models actually know probably can live outside of the model, right, and be like fetched in the moment. And so one of the things that I think some people done that, but actually training with RAG in the process. So instead of like right now, let's say and again, with synthetic data, you can actually do this more effectively. You can actually say like, hey, instead of like predict this next word, like beginning of the document, predict next word, right? That's the kind of setup. Like, and you have no idea what's going to happen. And then you like, let's say you imagine you're trying to you're trying to predict a Wikipedia article about like, I don't know, some castle in Germany, right? And you have model has no idea what the hell this is, right? So it's like just like a high level distribution of like castle-y words. But let's imagine you actually fetch some articles about this castle from other pages and put them in the context, and you say now predict those, and you don't back props to the first part, but you gave it context on like what it's going to be writing about, and now it doesn't need to learn the facts, it just needs to learn how to fetch information and reason about information that came in the context properly, right? So you're training it to learn how to reason about like more sophisticated contexts that contain actually answers and contain the information. And this is like, you know, what I was back in the day doing at Google was that is like you have Wikipedia article and a question and you're trying to answer. You were training that way instead of just predicting next token. And it's definitely a more effective way of training, but it's harder to get data in that way, right? Because like and you may lose some things when you do that. So that's why like I think a lot more experimentation of can we like remove the need for it to memorize at least some like arbitrary facts and instead like learn mostly just the basic like thinking primitives.
Yeah, it's interesting. It's very related as well. We recently, like last week, released a research post on our blog. It's called Machine Unlearning, which is becoming a bigger and bigger kind of hotspot of research nowadays. Like how can you delete certain information from a model without fully retraining it? And the sign we are seeing in the market is that like people are not interested in running massive models with like trillions of parameters even. where a lot of these informations are not really related, let's say, to the business that they're trying to build for, right? Like they don't need information about the film industry if they're trying to do some kind of astrophysics, right? And right now, how we are seeing is that all of those information is kind of hogging your resources, and you have to run them. You don't have any choice, especially if you use the models from the open source ecosystem, because they have a lot of information. So from our perspective, we see is that like this indiscriminate data accumulation is probably not the future. It's about like selective forgetting and figure out like which information you need specifically for the case you have. And the architecture you mentioned, actually very fascinating. That also kind of falls into that criteria, right? Kind of almost like right now, RAG is comes after the output layer of a model, right? You kind of make it in the layers before that. It's very abstract, like how I'm kind of thinking about it, right? You kind of make it before that so that you don't have to have all those information in the parameters and like bloat the size of parameters so high, and then the cost of running the model is also dramatically lower in that way. So from our perspective, like machine learning, especially distributed machine learning, is important, but machine unlearning is becoming equally important as well as we go.
Yeah, I think there's multiple sides here. Yeah, like kind of can we indeed, especially when you like fine tune for your specific problem,
Yeah,
like it naturally kind of forgets some stuff, right? That's just like how statistics works. So you controlling for what it forgets is a really interesting problem. I think people do a lot just like by generating a bunch of like synthetic examples for their fine tuning real data to like make sure it remembers the stuff they actually care about as well. And so like there's all these tricks, right, to do it right now. But I don't think there's like a fundamental approach which says like maybe it's like almost like a generative adversarial setup, right, where like after training a batch, right, you actually check that it's like its scale divergence from the original model is, you know, the like in this direction that like you care about, and it's losing the things you care about, and like you don't care about, and it's gaining things you care. So like maybe there's interesting side there. But
because we're
I'm
coming
more
up with sorry to interrupt. I was going to say like we are coming up with new model architectures live over Twitter.
Yeah, over Twitter, yes. Yeah, I mean, for me, I was actually always thinking more like, can we get it more that it learns like fundamentals, and then you go and you apply it to different spaces on top. So like the kind of the core model is like as de-biased in the first place, and you almost punish it if it remembers like specific facts, and instead like can derive things from scratch. That type of model, like it's almost like follows, you know, this philosophy, like basic principles, versus being like right now, because right now we're training it to be like, you know, speak like a human, and like have, you know, and you can like, oh, and pretend you're this, like now you're able to do this, like, you know, let's just remove all that, like get the basic like intelligence unit, and then you can like use it in different contexts on top, right? And so that's why I was like, I think one way to do that is actually if you have a like synthetically generated data that is more about using context information to answer questions or to write articles, etc., versus trying to remember the facts, so that like next time you write an article about the same castle, the same star, you actually know it is as facts, right? So like the facts are always kind of given to you.
Yeah, no, that's fascinating. Makes sense. I have a lot of thoughts on that, but I actually have like a different, also curious to know your thoughts, like outside of the tech stuff, is that the, you know, business side of things, like the Web3 AI, Web2 AI. And I have my personal experience in that too, but want to know your experience. Well, is that like what was the experience when you tried to kind of sell the vision of user-owned AI using the Web3 technology to the mainstream Web2 AI people? What was the reception from them?
Yeah, I mean, I think there's like different type people in different camps, maybe.
Yeah.
There's obviously like AI researchers who are more interested in advancing the research, and so like how it's applied, it's kind of secondary for them.
Yeah.
And I think there it's more about like, can we use the open source? Can we use incentives to like do better research?
Yeah.
Or like a very specific examples like crowdsourcing, right? Using blockchain for crowdsourcing is just like way more effective. Like you can get a lot more done for cheaper. And that specific use case, for example, people are excited because like, hey, I can get more data for less money faster because it can like scale up as well. Great.
Yeah.
There's a camp of obviously people who are in big companies who are like, there's nothing wrong with the big company having all your data and providing you best experience that it can provide, right? I think that's a hard like argument to reason about, because like I would say the coercion that kind of being outside of that you see is like really hard to like present until it's really like until it's very negative, right? Like this like slow boiling of the frog, right? Like we give out our data, TikTok is like keeps sucking you into it, and you're they're better and better at like predicting what you're gonna spend more time on, and and then I think there's a camp that like kind of recognizes like that data privacy is important, that but they're not gonna like particularly do anything about it. And so this is where for us is like really about building really good products or better products that have privacy kind of inherent to it.
Yeah.
Also, I think like the data privacy will just become like a cheaper way to run things. I think just like the cost of holding data will keep growing, right? The GDPR, the California laws, the like
HIPAA,
the cookies, like this, HIPAA, like it just keeps growing, right? Like so, like at some point, like it's just gonna be like, if you want to deal with private data, it's like so expensive that actually like dealing it in a privacy preserving way is just cheaper. And like it's like for us to drop the cost, like right now it's this cost is growing and this cost is just high. And so for us, it's like with technology and innovation, drop it under this. That's when I think we'll see like a shift. And so I think like there's people who recognize this balance, and right now it's just like it's not like I can go to like dataprivacy.com, use the SDK and I'm done, right? Like there's no like whatever, like a Postgres but private, for example. Like I want to run Postgres but private, right? There's no like offering like that right now that's like scalable and can serve 1 million users. So I think like as we're getting there on different dimensions, I think that will become important. And then there's people who are who are joining Web3 AI space because they actually see the value and excited about it. And so I think a lot of people already recognize that like our addiction with tech and kind of is not healthy, and we need a new way to approach this.
Yeah, it's interesting you mentioned that, because I read about this somewhere, is that like the whole reason you left Google to start NEAR, it was the AI company earlier, and now it has become the combination of those two, blockchain and AI. But and correct me if I'm wrong, but I guess the goal was to build products which kind of consumes or aggregates more data through the product itself, and so that you can build better and better AI models. Is that a correct information?
Well, so I left because I wanted to build a product that will have a feedback loop with the user, right? That was the kind of fundamental part.
Mm-hmm.
And the piece that was not clear, like at Google, like that you could build such a product and actually go to market with it, right?
Yeah.
And like there's a bunch of reasons for that, including like I have tried to launch some products out of research, and from a data perspective, I mean, when we started NEAR.AI, I like we definitely were not thinking about like data privacy per se. We really thought more about like how do we change the user experience, the
Mm-hmm.
consumer experience with AI, pretty much, right? That was like pre everything idea of like, hey, if you have an AI that can write code, like the user experience will change dramatically, right? You don't need SaaS software, you don't need applications, you'll just build stuff on the fly.
Yeah.
Meanwhile, let's build something that like can build applications, can build SaaS software, and like iterate to improve it so that we get there to that future.
Yeah.
I mean, I think we were just like there was like research around like, can we actually do that? It was too early for like thinking about data privacy and stuff. When we started exploring the blockchain side, right, which we were like wanted to use it for our own use case to collect data, like the crowdsourcing was kind of our main use case itself. Obviously, that became a lot more clear that this is like one of the fundamental offering. The incentives is one of the fundamental tools, and you can use all of this to like create a new type of internet, new type of applications and services. And AI is kind of your interface, right? It's the way you interact with it, and kind of in a way like build functionality or provide functionality. Yeah.
No, yeah, it makes a lot of sense, and I'm glad you did. Like, you changed both the AI. After changing the AI landscape, you changed the blockchain scalability landscape as well, which we in the community are grateful for, of course. But yeah, I totally kind of identify with this data privacy, stress on the data privacy. Like, that was my experience too when I tried to kind of sell to a lot of these people, who are in the mainstream Web2 AI community, who are not necessarily, like DeFi traders, and doesn't really interface with blockchain in a day-to-day basis. And they're like, so if the pitch was to them like, hey, if you have some AI which is built in decentralized way, then the government cannot come and take your AI. And they're like, get out of here. Like, I don't care about government taking my AI. I probably have bigger problems if the government is coming after me. But when we kind of pitched them like, hey, but you can actually have your own data privacy. You can have monetization, or you can even interact with people to do edge compute, which gives you better performance for your solutions. Then you get like 10x better solution with probably 10x less cost. Then all of a sudden they are very interested. Like, hey, how can we use it? So it's like the technology that we have in the Web3 space is like very, very primed for disrupting the AI space. It's up to us how we present it to them, to the mainstream market. And if the presentation is done in the proper way, they are like really excited. Like, I personally get more excitement when I talk at a AI event, like a Web2 AI event, but we're talking like decentralized AI, you can do this, you can interact with people. They're like, oh, this is like science fiction. And the person before me, who were presenting, they were probably building some AI customer chatbot. So they hear that, then go to this decentralized AI. So they're like, wow, this is amazing. You guys are doing really cool thing in the space, right? So I actually get like more excitement from the Web2 AI folks when it's presented the correct way.
Mm-hmm. Yeah, I mean, for sure, I think like definitely people are interested in seeing how, because like I think the ChatGPT kind of made it more acute. Like some of the like, oh, my data is used in a weird way. Like then Reddit, sold everybody's data for some money, right? And so like
Yeah.
you kind of starting to see like, oh, like all the things that like, and like Filecoin or RV like were good examples of communities who were like telling a lot like, oh, your data worth something, right? We also were telling that for a while, but like now people actually see that, oh, actually my data is worth something. Reddit just sold all my data for this many millions, right? So I think that there's like just a lot more appreciation for that, and kind of it's a lot more on in mass media as well, and obviously for a lot more people came into AI where data is like one of the main resources. So like now pretty much any engineer who is like has some curiosity is poking around AI as well, right? So so yeah, I think it's definitely primed, and companies, corporations are also looking into this as well, because for them it's pretty fundamental to, if they mess up private data, they'll have huge fines, right? So this is and like this landscape is changing very fast and in a very unclear direction, right? Between all these regions, like what China does, what Europe does, what US does, is like completely different. So so it's like, as you actually, the edge computer is a really good example, because if you just push the model to the user, and then you can actually have a better product, because you can have access to all of the data of like where they've been, what they visited, what they're doing, what they're looking at, and you don't need to deal with it, right? Because if you try to get all this data to your computer, I mean, to your servers, like that's a massive issue. But if you just send a model there, and because you have all this data, your model can actually be way better at predicting what this user will want, or recommendation ads, whatever you do, right? So like edge compute is definitely like just a lot more effective, because it has access to wider data about the user, and in turn, indeed, you can build better product, and better product is how you're going to win. So
yeah, that's the whole idea of Apple Intelligence, right? Like they're doing this edge compute on the private devices, and you can do whatever fancy stuff with it, and it gives really highly customized experience. So that's great.
Yeah.
But I also like would love to know your thoughts on like what's your priority right now with NEAR. I know like this AI and Web3 intersection, I guess especially for the AI and Web3 intersection and your work at NEAR at the moment. What kind of solution you're looking to see the most?
Yeah, so I mean, the way we approached it is like, how do we bring together almost a stack of projects and offerings? And so, if you can imagine, you have like a closed source like Google OpenAI lab that has a whole host of things internally, and is able to like effectively build and use that, and kind of people can collaborate, etc. In open source right now, we have like pretty much a scatter plot of things, right? There's like hundreds of tools, but they don't work with each other. There's in Web3 AI, there's hundreds of companies, but they like all have different business models, different tokens, different like APIs, different ways of interacting, etc. And so and you have open source researchers who maybe don't even know there's like kind of this decentralized AI space, and then they themselves are like building stuff in open source, but then it's not like very reusable. So how do we like bring it all together and really create like a striving environment that is competitive in velocity of research and velocity of product building, that you can do all of that research by combining all of those different providers, like you guys who are doing fine-tuning, maybe somebody's doing inference, somebody's doing like providing fresh data, somebody's offering agent to agent payments, and then going and bringing top researchers who are in academia, who don't have access to this compute, to this data, to some of the benchmarks, like bringing them like, oh, here's a platform you can build innovative solutions on. So really kind of being the conduit of this like open source research, and creating velocity in it.
Yeah, no, makes sense. Love it. We also love research. We are a small team, but we have done quite a few actually fundamental research in the space. Haven't gotten to the kind of level of transformer paper yet, but we hope to get there at some point. where yeah, like we have this. It's like a kind of plug for this too. Like we have this research blog. Like everyone, please check it out. blog.bagel.net. Yeah, it's really popular among the research community. It's pretty new. Like we have been doing this for 10 months, but yeah, it's read over 112 countries worldwide still.
Awesome.
Yeah. And yeah, Illia, I'd love for you to check it out and know your thoughts as well.
Yeah, I just opened it, so I'll check it out and we'll let you know. All right, well, awesome. Well, thanks you for coming. We're at the hour, and been really awesome conversation. So yeah, everybody go check out the blog, and I'm sure we'll see more things that we can work together on later on.
Yeah, looking forward to it. Thanks for having me again.
All right.